All right, hi everyone, welcome back. In the last video, we did our first example of a transportation problem using the so-called table approach. What I'd like to do now is show you a different layout than the one that we have. And this layout is a little bit nicer, a little more transparent, I think, for smaller examples. It doesn't work as well for large, but again, for small examples, I think this is great and just gives you another way to sort of attack a problem if you get one of these transportation problems to model it inside of Excel. So let's just remind ourselves of the data, the inputs from the last question. We have three factories that are supplying products: Des Moines, Evanston, and Fort Lauderdale. We have stores in Albany, Boston, and Cleveland. Okay, we're going to abbreviate this as ABC and DEF. As a friendly reminder, all the shipping costs are provided. So they're here in the image that I screenshot from the last video. We have D to A, B, and C, $5, $4, and $3. Evanston to A, B, and C, it's $8, $4, and $3. And then from Fort Lauderdale to A, B, and C, 9, 7, and 5. Great. Those are all given. Those will always be given. Our outputs, the ability of our factories to produce certain items is always limited, right? You can't produce an infinite amount of items. So we have 100, 300, and 300. And then our demands, what's being demanded by our stores, you get the call says, please ship me this stuff immediately. A, B, and C is 300, 200, and 200. In the prior video, I started off with 300, but hopefully you fixed that as we went along. And so our goal here is to minimize the total cost. That's our objective. And of course, our constraints are you can't ship more than what the factories can produce, and you can't send less than what's demanded. You want to meet demand. So let's create an alternative transportation problem. This one's just a bit more nicer, I think, to lay out. So we have our origins or factories, whatever you want to call them, just where things are coming from. And here, you'd list it out. And so since, like in the past, in the last one, we had Des Moines, and we listed it once. And it was nice. It gave us a small spreadsheet. But really, Des Moines can ship to 3 places. So what you do now is you list it 3 times. And then you have Evanston. And last time we listed it once, but now since you can ship to 3 places, we listed 3 times. If it could ship to 4, you listed 4. If it could ship to 5, 5, and so on. And then, of course, you have Fort Lauderdale. I always struggle to say that word. Fort Lauderdale. And again, since it can ship to 3 places, you list it out. So you just give a big list. And again, this is why this doesn't scale necessarily, although Excel has lots and lots of rows that you can fill in, so you can certainly use this for many, many problems. Then you say, okay, so I have all these origins, and where can they get shipped to? So we put our destinations, our stores, wherever they're going, customers, and you list out each single one. So we have Albany, we have Boston, and we have Cleveland. Now it's a longer spreadsheet. It's not as concise, it's not as pretty, but you list it out. And now you have every possible combination that you have. You have 3 choices for the first, 3 choices for the second, multiply together, and you get 9. That's fantastic. All right, what else do you want to keep track of? Again, what's the data, what's given? We have our unit cost. So we take our unit costs, and these are all given, and you type them in. So 5, 4, 3, 8, 4, 3, 9, 7, 5. And the last thing you want to know, we'll call it our shipments. These will be our variables, our decision variables. What do we want to send from each origin to each factory? And we will color code these green. Then we'll make this a nice pretty table. Okay, everything here is the givens. So the next thing we need to do is put in our supply constraints. This would be our factories. What are we able to supply? We have Des Moines, we have Evanston, and we have Fort Lauderdale. And you want to think about what they're able to produce. So what is being, what should we call this, our outflow? What is actually produced? Now this we have to keep track of. Let's put in some dummy numbers here. Just because. So let's do 2, 2, 2, 3, 3, 3, 4, 4. Obviously, these are the wrong answers. These are just dummy numbers. But let's count how much is actually going out. And remember, we have our sign, and then we have our capacity. And you have to stay under. What actually is going out has to be less than or equal to the capacity of the plant. So I have 100, and 300, and 300 again. So I need to count. I need to find a way to keep track of what's being sent out. Okay, we can do that. This is a new formula for us. If I asked you to take this table and sort of count, there's 2 ways you can do it. The long way to do it, the not so pretty way, is to say, all right, well, let's add up Des Moines, going to Cleveland, add up Des Moines, going to Boston. You can do it this way, like sort of select each one, or maybe you can get clever and do a sum. They happen to be in order, but I'd just like to show you another way to do it. You can always use, this is probably the more, I guess, advanced way to do it, but you can use what's called the sum if formula. And this says, tell me what I'm summing, what's my range, what is my criterion, and then well, what should I sum? So the range here, since we're looking for Des Moines, is we say, go look for the table for Des Moines. What is my criteria? Well, I'd like it to match. So search this entire column, find Des Moines, and then let's range. What should I add up? Add these here. And it knows to match the row. And when you do that, close the parentheses, hit enter, it correctly gives 6. And notice if I update something, say here, to 3, it counts it correctly. And this is great. I want to drag this formula down. This would scale up with my model. Nice little hack here. So let's put dollar signs on it. Both A4 on both A4 and A12 to D4, D12. Hit enter, and we'll drag this down. So that's a nice little formula. I'll put the formula text on that so you can see it. Is it the easiest way to do it? Did we just kill a mosquito with a cannon? Probably. But it's a nice way to scale up. Let's add now our demand constraints. So we're going to make sure in Solver that our outflow stays under our capacity. And then for our demand constraints, let's look at our factories one more time. I guess this will be our stores this time. We have our stores. We have our inflow. And here we really want to be equals or even greater than equals. Let's do greater than or equal. And this is given. You can always send more, I guess, but it's going to be not very cost efficient to keep sending more. The demand here is 300, again 200, and 200. And our stores, will list them off as Albany, Boston, and Cleveland. I will copy and paste that from above. And now we have our tables. Let's do the same inflow formula. Let's use the sum if formula. So it says range, where am I looking? So let's look under our stores. What's the criteria? What am I checking for? Well, let's go actually get the store name. And then what am I adding up? We'll add up what's being shipped in. So now I can actually track of what's going to Albany. Again, I could have clicked the Albany, Albany, and Albany, and you can see 4 and 3 and 2. It does add up correctly, but I want something I can scale up and drag down. There's no reason why these have to be sorted the way they are. So this is just a more advanced way. Put dollar signs on everything so we can drag it down. Hit enter when you're ready and drag to get. I'll put some borders on the tables just to make them a little more readable. We like pretty spreadsheets. We'll center everything for readability. And there we have it. So this captures all the same information as the other spreadsheet. It's just a different way to see it. And again, because this is a relatively small example, we are able to do this template. The one thing and the last thing we need is our objective function. I'm running a little bit out of room, so let me zoom to make things smaller. I'll put it right here at the bottom. Our objective function, as a reminder, we are trying to minimize the cost. Now this is a little easier to do. We'll color code this gray. If you want, pause the video here and see if you can come up with a formula that would find the total cost based on this spreadsheet. Ready? What do you want to do? I'm going to ship this many things, my variables, at these costs. So 2 things from Des Moines to Albany would cost $5 each. 2 things from Des Moines to Boston, $4 each. Well, that is just multiplying and summing as we go. So of course we're going to use our sum product formula with all the unit costs and then all the corresponding shipments. The order on which you highlight doesn't matter. Hit enter when you're ready and you get, at least with these dummy numbers, 156. We're going to get, hopefully, the same exact answer as we had last time, but of course we need Solver to find that for us. So once your spreadsheet model is correct and you understand it, again, don't just copy me as I go through it, make sure you understand it. Let's head over to Data, to Solver, and let's go ahead and fill in all the information. Let's set our objective function. Again, if it's color-coded correctly, it's the gray cell, helps us find it quickly. We want to make sure we're selecting min, and we want to change our green variable cells. So 1, 2, 3, make sure those are all set. Let's add some constraints here, and now you can also see the benefit of this template. It matches what we're used to with our constraint table. So I have my outflows. Let's do batch upload here. All of my outflows need to be less than or equal to all my constraints, and then we'll add another one. And then all of my inflows need to be greater than or equal to my demand. You can put equals here as well, you get the same answer, and you hit OK. So we have our 2 demands, our capacity demand, from supply, and then from the stores what they are. Select the box, or make sure it's selected to make unconstrained variables non-negative, and select simplex LP. Solver found a solution. All constraints and optimality conditions are satisfied. Hit OK, and we're good. And if you remember, the 3,900 was exactly the same number that we got last time, so nothing's changed. Nothing's changed at all, just the layout, just the organization of the spreadsheet. And from here, of course, we'd write a summary sentence, maybe put some units, put some dollar signs on these things, and then present it off to the next person on the team. All right, so just another way to do it. Pick the one that you like the best. Pick the one that you understand. Try both in the beginning until you find one that you really like as you work through the other problems in this course. All right, great job on this example. I'll see you next time.